Hi students, today we're going to work on some practice with finding the line of best fit. You have a paper that has 4 graphs on it. We're going to be working on graphs number 2, 3, and 4. You have another paper that has questions pertaining to these graphs where you will be asked to use the equations to interpolate and extrapolate the answers. You will also be using a program called Interactivate, where we're going to find, using linear regression, the line of best fit. So let's just review. Looking at graph number 2, here you have the relationship between test scores versus number of absences. So what would you predict? What kind of correlation would you predict there to be between these two variables? Would you say somebody with more absences will have a higher test score, or someone with less absences will have a higher test score? If you said the second, then you are correct, and we know that that is a negative correlation. So we're going to be looking for a graph that slopes down from left to right. For instance, 72 corresponds with 4. I would put a dot there. 65 corresponds with 6. And this is how you've done your scatter plots. You've plotted, and then you've made a trend line. Took 2 points from the trend line and found the slope, and from there you wrote it in point slope form, and from point slope form you were able to write it in slope intercept form. Okay, well, in science and math we don't have to do that because we have a function on our calculators called linear regression, and I'm going to show you how to use that. Here's a program that you'll be accessing. Okay, what you're going to do is put your points into this plot box as shown. So your first point is 72, 4, and you'll put that in. Your x-coordinate is 72, your y-coordinate is 4. So you put in 72, 4, hit return. And you go on doing that for each and every point and hitting return after each. So x-coordinate, y-coordinate, return. Okay, you go ahead and do that. And when you do, I will tell you what to do next. So pause, continue inputting, and then restart the video after you have put in all of the, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. I think there's 10 data points, so you should have 10 pairs. Pause the video. Okay, students, we're back. At this point, you should have put in all 10 of the coordinate pairs, okay? And make sure you check them and that you have, in fact, done them all and you've done them all accurately. If you scroll down, you should have all 10, and I would urge you to go through and make sure you did them all. Okay, if you have put in all the points, it's time for us to have our regression program do the linear regression for us. So what you'll do is you will click on Update Plot. What you'll see is your scatter plot. And this is exactly what you put in. It graphs the points according to what you put in the plot box. Okay, now what we can do is we can say we would like the program to display the line of best fit. And what the program will give us, it will give us an equation in slope-intercept form that accurately describes the relationship between the two variables, test score versus days absent. Okay, so here we go. So the computer drew a trend line through for us and gave us the equation, which I'll explain what the R equals, what that has to do with. The equation is y is equal to a negative 0.241x plus 20.13. Now, what I'd like you to do for our purposes is I'd like you to round everything to the nearest hundredth place, and I'll explain why later. It'll just make our calculations easier. So what we see here is we have the line of best fit and an equation. R, I mean. Okay, what the R value tells us, the R value is the coefficient of correlation. And the coefficient of correlation is a number that tells us how good or how close our points are to the line. It's sort of a measure of vision. So this is a negative 0.9. That's pretty close to what the ideal is, and the ideal is 1. So if it's a little bit higher than 1 or a little bit less than 1, whether it's positive or negative, that's a good correlation. So strong negative correlation here between test score and days absent. Okay, we're going to use this equation. What you're going to do is you're going to round off to the nearest hundredth place, and you're going to use it on your worksheet that everyone has. And that worksheet looks like this. Okay, switching over. Okay, so here you are. This is the worksheet that you are assigned today to hand in after you have completed doing the computer linear regressions, finding the equation for the lines of best fit, rounding off the numbers, as I told you, to the nearest hundredth place. So this equation became y is equal to a negative 0.24x plus 20.14, with both of those rounded. Okay, and we use the regression program at this address, which I will have on Classroom for you, and you generated this equation. And here we go. Here's the first question. How many days absent would a student be 75% on the test? Well, let's go back to the facts. We know that X represents the test scores. That was plotted on the x-axis. Y is a number of days absent. So we want to find out how many days absent. Okay, so we're looking for Y.
Good afternoon, Bronco.
Well, what do we know? We know that the student scored 75% on the test. So 75 is X, the test score. So all we need to do to find out what Y is, the number of days absent, is to plug 75 in for X. So a negative 0.24 X, that means negative 0.24 times 75, plus 20.14, and if we work that out on our calculator, my pen isn't working so well, we'll find that the number of days absent will end up being 2.14. And that's what we write in our answer space. Okay, if you have any questions, raise your hand and I am happy to help you out. You are responsible for all of the questions that have to do with each of the graphs. Good luck.